linear functions, and today we're going to talk about those graphs that we've created and how to transform them by changing our slopes and our y-intercepts. So first we're going to kind of take a look at a couple of equations and see what happens as some different things change. So the first thing we're going to look at is this equation y equals 2x plus 4. I'm just going to talk you through very quickly how to graph that. Notice I have up here a slope of 2 and a y-intercept of 4. So I know I'm going to start my graph here at 4 because that's my y-intercept, and my slope of 2 means I've got a rise of 2 and a run of 1. I'm going to go ahead and fill in another point on that line so that I can draw it reasonably straight. And then I've got another equation. Notice I've got the same slope, 2x, but my y-intercept has changed. Now my y-intercept is at -4. I'm down here. Actually, I'm going to change my pen color for a second, so I've got something different. I've got my y-intercept at -4, my same slope of 2, so it's still a rise of 2 and a run of 1. And now I'm going to attempt to graph that. Notice the only thing that has changed is I've had this slide down. My lines are still parallel, but I've got a vertical transformation down by 8 units because I've gone from up 4 to down 4. So I've had this vertical transformation down of 8 units. Let's look at one more example. This time I have different slopes. I've got 2x and 4x, but I'm starting from the same y-intercept. So I know that both of my lines are going to start here at y-intercept of 4, but my slope in the first one is the same as in that first problem. Where am I here? And I'm going to try to draw that line. And then in this second case, I've got a slope of 4. So from my y-intercept of 4, I'm going to go up 4 and over 1, and down 4 and over 1. So notice that my new line became much steeper than my original line. So a parent function. Parent function is where we're going to start all of our transformations from. The parent function is y equals x, or f of x equals x. That's that line that looks like this, where every y coordinate and x coordinate are the same. Here I'm at 2, 2, or at 4, 4, or at -1, -1. So that's my parent function. Any transformation is a change from my parent function to either another parallel line, which means I've got a vertical translation, or I'm going to have a rotation by making my slope steeper or less steep. So let's take a look at some examples. So first I've got a graph of f of x equals 2x, and then I'm going to transform that to g of x equals 2x minus 6. So let's take a look. Notice I've got my original line here of f of x equals 2x, and it's going through the origin because I've got my y-intercept is 0. And then I'm going to translate that vertically by changing my y-intercept to -6 so that I've got two parallel lines. Nothing's happened to the steepness of my line, but it has slid down my graph vertically by 6 units, and that would be this change of, this would be +0 if we actually wrote that out, this change from a y-intercept of 0 to a y-intercept of -6. So the graph of this section function, g of x equals 2x minus 6, is a result of translating the graph f of x equals 2x 6 units down. So notice, this is just a recap of everything. All these lines are parallel. The only thing I've done is change the y-intercept. Every single line has the same slope, Here I had my slope of 1 because without anything in front of my x, my slope is understood to be 1. I have my parent function here, f of x equals x. I also have a slope of 1, slope of 1. The only thing I'm doing is sliding up and down my graph by changing my y-intercept. Now I've got a graph f of x equals x, or my parent function, and I'm going to change it to g of x equals 5x. Well, we can see what that looks like here. My parent function here rotated to make a more steep line for g of x equals 5x. My slope of 5x meant that I had to go a rise of 5 and a run of 1, which made this line much, much steeper. So I rotated about this point, the origin. Both of them go through the origin and stay there, but I've rotated about that point to make that steeper line. And here I just have an example of several equations rotating about the parent function, and the parent function is still through the origin. And then I've got a line here that's green, that's exactly like our last slide, h of x equals 5x. I've got one that's a little less steep here, the red one, g of x equals 3x. And then notice I've got one that's even less steep than my parent function because my slope here is 1/2. So of course that's going to be even less steep than my parent function of f of x equals x. So these are all rotations. All right, so I am going to transform this graph f of x equals x to g of x equals 2x minus 3. So here I've got two things going on. I've got a change in my slope, because here my understood slope of 1 became a slope of 2. And then I also, because this was the parent function and went through the origin, have a y-intercept of 0, and now I have a y-intercept of -3. So I'm going to take this in 2 steps. My original parent function is this blue line, and that's going through the origin and has a slope of 1. So for every rise of 1, I've got a run of 1. Then I'm going to transform that by adding this changing this slope to 2x, which means still going through the origin, and then for a rise of 2, I've got a run of 1. So I've got a rotation here going to my green lines because it got steeper. And then I'm going to change this to this f of x to my g of x by having a vertical slide of -3, because my original y-intercept of 0 is now a y-intercept of -3. So that original blue line rotated to become my green line and slid down to become my latest red line of g of x equals 2x minus 3. So I've had two transformations here. One was a rotation from my blue to my green, and then a translation or slide from my green to my red. Here's my business application. I always like to have some kind of real world application in my videos. A florist charges $25 for a vase plus $5 for each flower. And so my original cost without adding any flowers was to purchase that vase. It was $25. So notice here my y-intercept is at 25. Let's say I put one flower in that vase. So now I am at $30. So my slope is 5 because each flower I purchase will increase my price by $5. So here's my original equation. Then it asks, how will the graph change if the vase's cost is raised to $35? Well, I'm going to get a new color here and see what happens if it's changed to $35. Well, first of all, my equation is now going to be, I'm going to change that to g of x, so that's showing that's my next equation. My cost of flowers is still the same. That's still 5 X, but now my y-intercept is going to be at 35 because my initial cost is going to be $35. So here I am at 35, and I'm still going to be parallel to my original line because my slope has not changed. Let me get yet another color, and now I've gotten yet another scenario where the charge per flower is lowered to $3. So I've got h of x, and I'm going to stick with my new y-intercept of $35. Since they've lowered the cost of flowers, now my slope is going to be just 3, but they had to keep that new increased price to cover that lowered cost of flowers. So instead of increasing by $5 every time, I'm going to increase by just $3 every time. So my new slope will be less steep than my original. I've had a rotation down to my new slope of 3 with my same y-intercept of $35. So hopefully you're working on that chapter test review, which was online on my calendar. Look at Friday's date, click on the calendar date, and then open up as an attachment at the bottom will be that practice test. Please bring those in tomorrow so that we can take a look at those and go over the answers.